Hello, today we'll talk about tangent, what definition of tangent. For these lessons, we're going to look at, before we're looking at triangles in general. Now we're going to look at right angle triangle. A right angle triangle is a triangle that has one of the angle has a 90 degree. Okay, so for example, this particular one, and it's denoted using this, is denoted as such. This is represented 90 degree. Okay, so whenever you want to show that in your triangle there is a 90 degree angle in it, then you do this rectangular box inside, and this is also called the right triangle. So over here at the moment I have two triangles, and they are supposed to be right angle triangles, and there are similar triangles at the moment, and the big one is A dash B dash C dash with the height being 8 cm and the base being 20 cm. The smaller one has a base of 5 and the height of 2. So what I'm going to do is that we talked about before is that the angle, right, is this one. These two angles are the same, and in fact, if you do a bit of exploration, and you will find that if you take the ratio of the height over the base, that will also give you the same, that always give you the same value. For example, in this case, 2 over 5 is the same as 8 over 20, right? The ratio are going to be always the same. And I can move this back into here. You can see that the ratio give you exactly the same angle, right? So when we're concentrating on right angle triangle, we can look at this particular angle here, and we look at the height and the base. So if you want to have the height over the base of the right angle triangle, and for this particular angle, because these two help to determine this angle here, A, so we call this particular ratio tangent A. And in terms of notation, we will usually write the side opposite the angle capital A is usually denoted with a small a, and similarly the side opposite the angle capital B is denoted with a small b, and this here, the side opposite angle C, capital C, is denoted with a small c, right? And tangent A is usually written as a short form as TAN. Tangent A now can be expressed as height A over B, right? And sometimes people call this angle, is the side that is opposite the angle, the opposite. Just opposite, the opposite side, and the side that is adjacent to this angle A is called just adjacent. Adjacent means near to, and this line here is called the hypotenuse. Alright, this line is called the hypotenuse. So tangent A of a particular angle is defined as the height over the base. So this is A. Similarly, I can also define the tangent B. For example, this is B, right? So in this particular case, where is the opposite? Well, the opposite is this, is B. So tangent B is going to be B over, and the adjacent now is A, because this is always the hypotenuse. Hypotenuse never change. So adjacent to B now is A. So now you have B over A. Tangent A is A over B, and tangent B is B over A. Right. At this stage, let us go and try out this special triangle. This is actually a triangle with here 90 degrees and 45 degree here and 45 degree here. So this length and that length is the same. At the moment, I just call it 1 and 1, 1 unit and 1 unit. And using Pythagoras theorem, you can calculate the hypotenuse, and the hypotenuse happens to be square root of 2. So what is the tangent of 45 degree? Well, tangent 45 degree in this case is the opposite. The height here in this case is 1, and the base is also 1, or the adjacent. So in this case is 1 over 1. So tangent 45, oh sorry, I made a mistake. Tangent, 45 is 1 over 1 is just 1. And that's it, finish. Tangent 45 degree is 1, so we need to know that. How about this side? Well, it will be the same because this is 45 degree as well. Next, example number 2. Now we're going to look at this particular one. This is another triangle with 30 degree as this angle here. The red one is 30 degree and the green one is 60 degree. And obviously this is the rectangular one, that's 90. The hypotenuse is 2 and the height is 1 and the base is square root of 3. So we try the first one. How about tangent 30 degree? Tangent 30 degree over here, the opposite here is 1. Very good. And the base is square root of 3. And how about tangent 60? Can you try this out first before you look at the answer? Okay, alright, good. So where is the opposite in this case for tangent 60? Well, the opposite here is square root of 3, and the adjacent in this case is 1. Right? So here the adjacent here for 60 is 1. And then the opposite of 60 degree is square root of 3. So that's how we work. And you might want to memorize this value here. They are very useful. So tangent 45 degree, 1. Tangent 30 degree, 1 over square root of 3. Tangent 60, square root of 3. And it involves square root of 3. So which one is larger? Well, obviously square root of 3 is larger than 1 over square root of 3. So now we move on to example number 3. Now, example number 3, we have kind of an application problem here. We have a triangle here, right angle triangle. The base is known to be 1.2 meter, and the angle here is 60 degree, the green angle, and the height A is unknown, and we want to find what A is. So here, because we have an angle and we have the height and the base, so how are they linked together? Alright, very good. We link them together using tangent, because tangent link the height and the base together. So we will write that tangent 60 degree is equal to A over 1.2. And A becomes, rearranging this formula, becomes 1.2 times tangent 60 degree. Now, you could use a calculator to figure out what tangent 60 degree is, but we don't have to because we just did this. In example number 2, tangent 60 degree is square root of 3. So now I can have an exact answer. In the IB examination, it is best to give an exact answer. For example, square root of 3. So here is an exact answer. So A is equal to 1.2 times square root of 3. Obviously, if you do want to see this in decimal expansion, you have to use a calculator for this. Alright? Okay, next, example number 4. Example number 4 now, we have a right angle triangle ABC, and the sides are all given. But angle A in green, now I want to figure out what is angle A. I like to figure out what angle A now. Before I like to figure out what the side is, now I like to figure out what the angle A is. Now to do this, I have many ways to do this. But since we are learning about tangent, so we're just going to use height over base. We're going to link height over base. That's the ratio of height over base. So tangent A in this case is 5 over 12. And in order to solve for A, we do this. A is equal to move the tangent to the other side. Moving the tangent to the other side become, some people write this as arctangent. In the IB, this is preferred, arctangent. Or in the Japanese textbook, this is written as tangent to the power of -1. It means this is the inverse of tangent. right? Arctangent and tangent here means the inverse of tangent. Colloquially, you can think of this as the opposite, for example, right? So this operation is tangent A, and I want to take away the operation tangent. So you have inverse tangent. So this is, now, I don't really know what this is. I have to use a calculator. So if you use a calculator, then you figure out that this answer here is roughly 22.6 degree to 3 significant figures. In the IB exam, it's best for you to report your answer exactly, and if it's not possible, express your answer to 3 significant figures like this, 22.6 degree. And make sure that you always write the degree with this little circle on top, because without that little circle on top, this does not mean degree. Okay, so now we come to the last question. The last question here, right, is a very simple application problem. So here we have a very tall wall, a very high wall, right, and we have a ladder, and somebody, let's say Albert comes along and put the ladder here, so that the ladder is touching the top of the wall, and the ladder is known to be 3 meters in length, and the other end of the ladder is placed on a horizontal floor, and this, we assume that the wall is vertical, right? Vertical, and the other end of the ladder is 2 meters away from the wall on the ground. And Albert wants to know, what is the angle A here? Well, this question now, can you see the similarity between example 5 and example 4? Excellent. Yes, that's it. We're going to use the same procedure to do it. That is, we need to have the height and the base. But now, the complication here is that, well, do we know what the height is of this wall? Yes, the information is not given directly, true, but we can figure that out using Pythagoras theorem. Remember that Pythagoras theorem? Like, say, if this is B, this is A, this is C, this is, right, this is a 90 degree right angle triangle. Therefore, C square here is equal to A square plus B square. So similarly, I can figure out what the height is. And let's call the height here, the wall height here is small a. So A square is equal to, sorry, in this case, 3 square is equal to A square plus 2 square. Alright, and A square is equal to 9 minus 4. A square is equal to 5. Here we're going to have two answers. A is equal to square root of 5 or negative square root of 5. Obviously, you can see one of these answers should be rejected. Right, this one, right? Because the height of the wall cannot be negative. It has to be a positive height. So we have to say A now, in this case, is square root of 5 meters. Therefore, I can now continue. Tangent A is equal to height square root of 5 over the base 2. And A itself is arctangent, that is the inverse of tangent, square root of 5 over 2. I don't really know what is this from the top of my head, but I can use a calculator. So you use a calculator, tick, 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 and if you've done this correctly, you will get a result 53.1 degree, 3 to 3 significant figures. It is a good idea to always write 3 significant figures, 3SF here, to indicate that you are approximation, and use the approximation sign and not the equal sign when you really mean approximation. And don't forget to have that little circle to denote that this is an angle. Writing it as 53.1 is not acceptable, because later on 53.1 is meant 53.1 radian, which is not the same as 53.1 degree. So thank you very much.